Alright, today we're going to talk about how to make a system of equations. So you have 2x plus y equals 5 and 3x minus y equals 15. And so whenever you have a systems of equations, you have two variables. You have the x and the y, the x and the y. And remember, if you ever have a y just by itself, that means it's 1y, 1y. Alright, let me clear some of these annotations so that it's easier to see. Basically what you're going to do when you're doing systems of equations is you're going to figure out what variable is easiest to get rid of when you're doing it by elimination. The easiest variable to get rid of for this problem is the y's, because you have a negative y and a positive y, and you add the two equations together. So 2x plus 3x comes out to be 5x, and a positive y plus a negative y is just 0y, so just plus 0y. And finally you have 5 and 15, and you're adding those two together, and so it's 20. And so this is how, whenever you have a 0y, if you put in 1 here, 1 times 0 is 0. If you put in a 2 here, 2 times 0 is 0. So no matter what you do to this number, no matter what number you put in there, whether it's 0 or a million, it cancels out, because y, anything times 0 is 0. So what we're left with is 5x equals 20. And to get rid of the 5 on this side, this is a multiplication, you divide by 5. So x is going to equal 4. And that is the first part of the problem. So we know what x equals. Now we have to substitute that x back into the problem. And I'm going to do it into this one right here. So we have to substitute x back in to find y. So we have 2x. This is the original equation. 2x plus y equals 5. And we want to figure out what x is, and we know that x is 4. So we're going to plug x back in. So we have 2. And the way you remember how to substitute, the way I remember how to substitute is this: I think of x as the teacher and 4 as the substitute. When you put the substitute in, that means the teacher's not there anymore. Just like at school, if a teacher is gone and the substitute comes in, the teacher's gone. So we replace the x with 4. And that's the only thing that changes in this problem. The y stays the same, the 2 stays the same, and the 5 stays the same. And then we multiply 2 and 4, and that's 8 plus y equals 5. Subtract 8 from both sides to get rid of the 8 so that y is by itself. And if you forget how to do positive and negative adding subtraction problems, all you have to do is look at the two things. You have how many positives? How many positives? You have 5 positives. 1, 2, 3, 4, 5. This is just if you forget how to do these kinds of problems on a regular basis. How many negatives do you have? You have negative 8 right here. It tells you negative 8. So you put 8 in. 1, 2, 3, 4. Oops. Let me erase that. So you have 2, and then 3, 4, and 5, and then you have 6, 7, 8. So you have a total of 8 negatives and 5 positives. A positive, one positive and one negative cancel out to 0. So all the positives and negatives that are lined up next to each other, those cancel out, right? And what are you left with after the 5 negatives and the 5 positives cancel out? You're left with 3, and they're negative. So y is going to equal negative 3. And the final, when you have it all figured out, you write the x and the y. The x was 4, so you put the 4 first, and then a comma, and we figured out that the y was 3, and so that's the final answer. You write it as a coordinate, 4 and 3. And that is how you solve a system of equations by elimination.